Okay, so good morning all and welcome back to the session. So friends, in previous session what we have seen, we have gone through with the advanced RAG optimization techniques. And from the RAG optimization techniques, what we have seen so far, like these are categorized into three main buckets, or what we can have the optimization we can do at three main levels. Uh, First one is query transformation level, or uh, query transformation, then query routing, and query indexing. Okay, so this is these are the techniques once we are talking from the retrieval perspective. Retrieval level optimization. And then generation level optimization. So what we have seen, the generation level optimization inside the advanced RAG optimization technique, this is very simple to achieve, and it's simple to implement as well. But once we're talking about the retrieval level optimization, then query transformation, query routing, and query indexing, a lot of things are there, and it is tough to achieve as well. Like we need to perform a lot of activities that what we have seen, and in order to improve the retrieval, there are different techniques what we have seen. So once we're talking about the query transformation, so what are the different techniques? Query rewrite. What else?
Multiple query,
Multiple query,
rack fusion,
RAG fusion,
query decomposition,
query decomposition, and it is
step
of
back
two
approach.
types: code and
Yeah,
independent
COT and
query.
independent query, correct. Then step back approach,
Step back approach
then hypothetical questions, hide.
and hide. Hypothetical question. So these are the things that we have seen in our previous session, and we are able to get the details in a good way, L- like how to transform a particular query, what the user is going to provide, and based upon that, we are able to see it is able to improve the accuracy as well, because whatever the question which is asked by the user over here, with the help of these query transformation techniques, we are going to convert or modulate or refine that particular query. Okay, so these are the things what we have seen in query transformation. Now there are multiple techniques. Now once we are talking about the routing, say you can take it in this particular way, like I'm having the different documents. Uh, over here say we are having this particular vector store, and it is pointing to these particular documents. Okay, so say certain documents are there with respect to the lang chain, and these documents are placed onto this particular URL. That is perfectly fine. But what if I'm having multiple documents, multiple stores over here? Say certain stores are with respect to technical documents, certain store are with respect to financial documents. So multiple documents are there, multiple document stores are there, and we need to route to a particular store in a good way. You can take it in this particular way. If I'm going to ask the finance related question and it is pointing to the technical vector store, then that will not make any sense. It will provide the incorrect output, right? Are you able to visualize? Let me mention over here. So routing is of two types: logical routing and semantic routing. Okay, so let me pick these particular things and we will be having the discussion on top of the routing, query routing techniques. Okay, so what I have mentioned, the query routing, this is of two types: logical and semantic. So what is the meaning of this and what exactly routing is? Say I'm having what I have mentioned, I'm having say technical documents, technical docs, and I'm having say financial docs. Finance docs. Okay, so I'm going to read the data and let me try to read it. Okay, so what I'm having is a technical docs, and I'm having certain documents over here inside the technical docs. Say document, and I'm going to hard code these particular things: page content, and page content, what it will be, say LangChain is a good framework. I can have different, you can say, documents, what I can create over here. uh, LangChain is having uh, Langsmith is good for tracing activities. Then Hugging Face is a repository of different LLMs. That is perfectly fine. What I can add? Can you tell me any line which I can add over here? Anyone? Can you tell me any line? Okay, LLMs are acting as a brain of RAG chatbots. Okay, so these are certain technical documents what I'm having, and what I will do, I will utilize these particular documents. Okay, so these are the documents. Although like you can read it with the help of different readers. what we have seen in our previous session, say if the PDF document is there, you can utilize the PDF reader, CSV reader is there. So based upon the flavor of document, you can have those particular documents, and you can utilize those particular documents in order to query on top of them. That is perfectly fine. Say the second category of the document, what we are having the finance documents. And if we are talking about the finance document, let me try to copy and paste it over here, and I'm going to change the content only. Yeah. So say finance docs. Say there are multiple categories of loans, and loan eligibility of a candidate is determined by CIBIL score and interest rate is varying for different type of loans. And what else I can have? Hmm. 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 Home loan is having less interest rate compared to other loans. Okay. So some sample documents I have prepared. Now, what I will do, I will say create the stores on top of this. Say I'm having text store. Text store, what it will do? So let me copy a line uh, from here. Okay. So say I'm going to create text store. Previously, I was creating what? I was creating the vector store. As I was having the single category of the documents. But at this moment, what I'm having the different categories of the documents. So I'm going to create the different tag stores or different vector stores. Just have a look over here. So this is the initial one, what we have used in our previous sessions. So what I will do, I will create the text store. I just replace this variable with text store, and I will keep the thing as it is, what is mentioned over here. And what I will do, so instead of this split, what I will use say technical docs over here, document equal to splits. So I'm not going to perform the splits because I have hard coded these particular things. What you can do, you can read the documents wherever it is placed, and then utilize those particular things. So document equal to technical document, embedding equal to embedding, I'm going to utilize the embedding model. Okay. And or what I can do, persist directory over here, what I can do, I can have say technical docs and say 2203. So this is with respect to technical documents. I can have the retriever as well. uh, Instead of this, so let me try to copy text store. This is the text store, and I can have the retriever as text store. So just have a look what I have done. I have created the the text store over here. Okay. And retriever, instead of retriever, I can have say tag retriever. Okay. So I have defined in this particular way. Same of format I can have for the finance documents. And I can say finance store. I can use this particular finance store over here, and instead of tech retriever I can have finance retriever. Okay, and instead of technical docs I will pass finance docs over here. Okay, is it fine with everyone?
Yes, yes.
Huh? Perfect now. So
Yes, sir. Yes, sir.
so
Yes,
what?
Yes,
yes.
yes, yes.
Perfect. So what is the main motto over here? Say if the query is asked, so which retriever I need to use? Either I need to use tech retriever or I need to use finance retriever. If say the query is with respect to finance store and I'm routing it to the technical tax retriever, I'm going to utilize the tech retriever, then the outcome will be incorrect, right? Because it will be pointing to the technical document, although the question was with respect to the finance. So at that moment, the outcome will not be correct. What I need to do? I need to define a way so that the query will be routed to a correct store. Either it might be the tax store or finance store. So I need to route the query to a correct store, and here the query routing is coming into the picture. So it is of two types. Routing the query to a particular store is decided by the query routing, and it is of two types. Logical, over here it is based upon certain logic. You are going to define certain keywords, and based upon the keywords the query is routed. We will see like how this particular stuff will work. Let me try to mention over here. So logical routing, when routing happens based upon keywords, metadata, or some logical rules. Logical rules. So that is nothing but the logical routing. We will see how it will work. Now, semantic routing. Over here, say when routing is when routing happens based upon say LLM intelligence, or what I can say, uh, or some, what I can say, or query meaning, or query meaning, what I can say, meaning. Then it is called the semantic routing. We will be discussing in detail like how this will happen. So we will see it through the practical. Like we will try to have the implementation of logical routing and semantic routing. Then we will see. Okay. So what I will do, I will I'm having this particular uh, notebook ready. Okay, and what I have done, I'm having some couple of imports, and I have defined the OpenAI API key. Then I'm not going to utilize this particular stuff. Like, I'm not going to load the documents. I will delete it, and I'm going to have. Let me rerun it, and I will use this particular stuff. Huh? Okay. I will define embedding, but I need to define the embedding. Embedding is not defined yet over here. So, where is the embedding? So this is the embedding, and I will define it over here. Okay, let me have it. Embedding, and let me try to to create the tech retriever and finance retriever with the help of these particular documents. Although what you can do, you can read the documents with the help of this reader loader functionality, then proceed for splitting and embedding of those particular things, and you will be able to have that. Okay, but as we are having these hard coded, you can say, documents, and we will be moving with these particular documents. Okay, so let me have the execution and check if what has happened. Document is not defined. So I need to define the document basically.
I have observed one thing
Mm-hmm.
from like hub repository, na, from LangChain import hub that is not working in Google Colab.
Okay, it's not working Google Colab. Okay.
Google Colab. Actually, I was getting error like it is it is not available in latest packages, something like that.
Okay, so I will check. Probably there will be certain other things instead of Hub. I am using
Yeah.
Python 3.10, so it might be possible there are certain other things that can be checked.
Yes, I also faced similar issue. So you used client in place of hub, so that
Yeah,
code
yeah.
will
Actually,
work it.
I have used that thing, that particular code, 2 lines code related to client.
Okay, so I need to import the documents. Let me import the document, and then I will be able to create these particular retrievers. So I have imported the documents. That is perfectly fine. Now, now what I need to do, I need to define the rule. Okay, I'm having this finance retriever. I'm having the tech retriever. So, so what the logical routing says, it will be based upon certain keywords and all. So what I need to do, I need to define certain keywords, and then will proceed uh, to selection of the retriever based upon those particular documents. Let me mention, say, uh, say if any, I'm going to utilize any word in say query dot lower for, and it will be say def logical router. I will pass the query that will be of string type, and then query lower equal to query dot lower. I'm going to convert it into the lowercase, Uh, Perfect. If any word in query lower for word in this particular category, say LangChain, Langsmith. I'm going to copy certain keywords over here and Hugging Face, and I can use say LLMs. That is perfectly fine now. If any word uh, in query.lower for word in this particular category, so what I need to do, I need to return track retriever. Elif Elif the finance store, and I just need to change the word loan, uh, CBIL, and interest rate. Let me mention interest only. Mhm. Okay, so finance store, like from the query itself, over here, what I'm going to from the definition itself, we are able to see that once we are going to route based upon the route to a particular store based upon certain keywords or a logic, then that is called the logical routing. And over here we have defined that particular stuff only. Yeah, so if these are the keywords, then it need to route it to the technical retriever. If it is tech retriever or tech, not tech retriever, it will be tech store. Not tech retriever, that is perfectly fine, and it will be finance retriever, not finance store. Okay, so I'm having tech retriever and finance retriever. So based upon this particular logic, we have defined it in this particular way. Okay, now the logic is defined over here. Now what I will do, I will ask the query. Let me have the execution of this invalid elif return. Okay, and I can give else as well. If like something else is there, then return tag retriever. Okay, so if anything is there with respect to loan and all, then it will retrieve the finance, it will return the finance retriever, else it will return tech retriever in any case. So this is, you can say, decided by with the help of these particular keywords what I'm going to mention. And uh, and this is, you can say, decided by the user only. User is going to define this particular logic and whatever keyword he is having, and based upon those particular keywords, the query is routed to a particular retriever. And once I'm talking about the retriever, it might be possible it is the tech retriever or finance retriever, once we are having the multiple retrievers available. Now what I will do, I will define a query and say mention say how LangChain is working. Okay, I'm having this particular query, and then what I will do, then retriever, what it will be, retriever it will be logical router, and then I will pass this particular query. Okay, query is not defined. And retriever, what it will be, print retriever, let me, so let me try to do it in this particular way. Docs equal to retriever dot get relevant docs, and I will pass this particular query for doc in docs print doc dot page content. Okay, so the main thing what I'm willing to say over here, I have written a particular query how LangChain is working. Okay, and retriever I call to the logical retriever. Logical retriever is going to check this particular query, and once it is able to identify a particular keyword, okay, keyword from the given keywords, then it will route it to that particular uh, tag retriever, it will route it to that particular retriever, and then we will be able to get the documents, so over here I have just written the query how LangChain is working. uh, let me change the question, let me change the question over here, and then I will have the execution of the same stuff, and then we'll see what is happening over here, okay, and say these are the documents, so I'm going to change the question, say what is say home loan, okay, and just have a look over here. I'm able to get all the documents which are placed inside the finance store. I have not mentioned the store over here, but the store is decided based upon this logical router, okay, what I have defined over here, is it fine with everyone, guys? Just have a look and ask if you are having any doubt, all of you.
100%. So the logical routing is working based on keywords or some like specific rules.
Correct, correct, and rules and keywords are defined over here,
Yes, yes, yes.
perfect, is it fine
Yes.
with everyone?
Yeah, yeah, fine, fine. Thank you.
Perfect, okay, so this is logical routing, now
So I have
mhm,
a question here.
mhm.
So we can use this query routing with query decomposition with both of them at the same time, like routing of this logical document to different pipeline and make the decomposition multiple queries. Is it possible we can
Yeah,
use
yeah,
both of them?
you can utilize, huh? Like
Yeah.
actually the query decomposition will happen based upon the query only, yeah. Okay. So
Yes.
and at the end, once you are going to ask the question to the large language model, the initial query is being passed, okay, and internally it will try to decompose, fetch the documents based upon the decomposed one, and then club it together and then provide the final answer, huh? Okay, ultimately what is being happening, it is going to to route to a particular, you can say, uh, store, right? A store is being utilized internally. If we are defining one store, then it is going to uh, to utilize that particular store to fetch the document, huh? Second, like one, what is happening over here, onto the routing, we are defining a route like which store it need to utilize, huh? Okay, so the you can either pass the initial query or the generated queries as well, then it will be able to utilize that particular, you can say, store in order to provide the outcome. Both of these things are, you can say, separate, huh? Utilizing a particular store in order to frame the answer. Second, then once the answer is, you can say, framed, how to pass it to the large language uh, model to provide the final answer, huh?
Okay.
Probably you are not able to get, let me define it over here. So what is being happening, query routing, okay, main task to use a particular store, okay, query decomposition, we divide the query, okay, so we divide the query, then what these particular query will do, they will use the store, use the store, okay, and use the store, how these particular queries, initial query and the generated query will use the store based upon the routing, okay. And over here, if the generated query are having certain queries are having certain keywords or certain logical comparison or certain semantic comparison, then that particular store will be utilized in order to provide the answer, so the query decomposition, we divide the query, use the store to get the answer, okay. Now if you want to utilize, the query routing over here, it can be placed over here in order to have the outcome, you are going to decompose the query, uh, query will be divided, then they can utilize this particular query routing and use that particular route to get the answer. And query routing is nothing but selecting a store, right? So you can utilize it and it will not impact uh, the functionality. Basically, yes, it can impact the outcome if multiple stores are there, and you are going to take the decision based upon this particular query routing. It might be possible previously the queries are routed to the different, you can say, data store, but at this moment, once you are going to leverage this particular stuff, query routing technique, then it might be possible the outcome will be more refined because you are having some more levels of searching, right?
Yes,
Okay, so it will be a little bit more good once you are having the multiple store in hand, huh? Correct.
yes,
You can utilize, and both of these two techniques are not, you can say, dependent on each other. These are working independently, yeah. These are working independently. It can work independently, it can work independently. It is not like say it will be dependent on this one, huh? Okay, you can club these particular things, you can have a chain, but these are independent functionalities, huh? You can use them in order to improve the accuracy. Correct.
that's fine.
Perfect. So it will work in this particular way. Now we are good with say logical routing, and we are able to route the query based upon these particular keywords and all. But what will happen once we are having the semantic routing? So once we are talking about the semantic routing, it is based upon the LLM intelligence. Just have a look over here. So what I'm going to do, what I'm going to do, uh, semantic routing. How we can implement this?
So semantic routing is related to like a distance method, like a closest one will pick something like that.
Uh, no, over here what we are doing, we are trying to identifying these particular keywords, and based upon these particular keywords, what I'm going to do, I'm going to take the decision that I need to use this particular retriever. Correct. But once it will be the LLM, what I will do, I will align the LLM to take that particular decision. Now, you will understand. Now, let me try to mention. Just give me a minute, and then you will be able to understand. So, say router prompt, I can define router prompt. I'm going to use the LLM. So I will going to define the router prompt, and it will be chat prompt template dot from template, and I will have the template. Now you are a routing agent. Classify the user query into one of the following categories, and I can define the category. One is a tag category, and tag category is a lang chain. I can define those particular keywords over here, lang chain, uh, say langsmith, and say data engineering, spark, ATL. Okay, and what else I can mention? Hugging face and all I can mention over here. Hugging face. Number two, then finance and say banking, loans, interest, home loan. Okay, so I have defined this particular category. You will take query, and query is of say this type query, and return only one word, tech or finance. Okay, finance, and this I can close over here. So I have defined this particular prompt. What I will do, I will have the router function at this moment. So def LLM router, and I will take query that is of string type, and I will have the chain. It will be router prompt I can give to the LLM. Router prompt, it will be given to LLM, then string output parser. I'm having the chain, and then this is the chain root equal to chain dot invoke, and invoke based upon what? Based upon the query. Query, and return. What will be the return from this? Return this root dot strip dot lower. Okay, and then def get retriever. So from this particular query, I will be getting, say, is it let me try to mention. So I will be getting tech or finance. From this particular function, I will be getting the tech and finance. That particular tech and finance, I need to give this get retriever function, and it will take, say, a root that is of string type, and mapping is I need to define over here. If it is a tag retriever, I can utilize these particular retriever, tag retriever and finance retriever. Finance retriever. Hmm. return mapping dot get fruit. This is default one. Let me define the query. And uh, hmm, let me try to call this particular and test. LLM route is not defined. LLM is not defined. Okay. Print test. Okay. Okay, so what is home loan? Just try to have a look over here. This LLM router function, what it will do, it will return a particular keyword. Keyword based upon what? Based upon this particular prompt. I'm going to pass this particular query. Okay, and this particular query will be given to this particular query is passed with the help of router prompt to the LLM, and then I'm going to invoke this particular chain what I have defined, and I'm able to get the outcome in terms of a single keyword. I have mentioned it over here only. Return only one word, tech or finance. So as this particular query, what is home loan? It is related to finance. Let me change the query. How to optimize LangChain. Okay, and just have a look over here, and it is providing me tag. This particular query is related to tag. Okay, now over here, over here, it is not like say I have defined these particular keywords. I have defined an example that if it is related to the tag words, the LM will return tag. If it is related to the banking, and these are the examples, then it will return finance. So over here I have given an example of these particular keywords. Okay, let me try to take spark etl, and let me try to mention a keyword which is not mentioned over here. Say how to optimize Python. Okay, Python programs. Okay, although the keywords are not mentioned over here, Python is not mentioned over here, but let's try to run this particular query, and what the LLM will provide. Is it a finance category or the tech category? Okay, so LLM is going to take, and it is providing me the tech category. The benefit of this particular approach is over here it is limited to these particular keywords. Okay, over here the the selection of a particular retriever is based upon these particular keywords only. If say I'm having any other keyword which is not mentioned, then it will use the tech retriever, which is the default one over here. So let me loan, CBIL, interest, and home loan. Any, can you tell me any keyword which is not mentioned over here with respect to the finance? Mm-hmm.
EMI.
How to calculate EMI? Yeah. Okay. And it will the previous one will provide me the tech retriever. How to calculate EMI? Yeah. Okay. What is logical routing? Mm-hmm. Probably it is not working. Is something there? The home loan is less interest rate. CIBIL. Probably our LLM piece and this particular stuff are mixing, so we are able to get the correct category. But what I believe, like, it will not work because we haven't given the context. Okay, it is working because we are having these particular things. So these are clubbed together probably, somewhere. Uh, it's uh. Let me try to check profit. So let me query one, and then query one. Dogs. Let me try to mention classify profit. Okay. Just have a look over here. So just try to have a look. I have given classify profit, and it has given me the documents. There are multiple categories of loans. Langsmith is good. Okay. So and let me retriever query one, talk about relevant documents. So it is pointing to both of the, you can say, retrievers. Right. Say it is going to provide me four documents, and four documents from the different, you can say, uh, different categories, and which is not correct basically. Langsmith, are you able to see? Guys, are you able to see?
Yes,
Langsmith is
yes.
good at tracing activities. So somehow like it is hard coded based upon these particular, you can say, keywords. But over here, selection of the retriever based upon the LLM intelligence. LLM is having the intelligence, and it is smart enough to decide based upon this particular given query. Okay, how to optimize Python programs. Although these particular things are not mentioned inside the keywords, but it is smart enough to check which uh, retriever it need to use. Okay, it is the tech category or finance category, and the things will be more typical once we are having multiple categories of the documents. Say HR documents are there, finance documents are there, R&D documents are there. So once we will be having the different categories of the documents, at that moment the LLM intelligence will work in a good way, and we will be able to classify that this is related to this particular category, and then we are going to use that particular category in order to get a particular data store. Okay, so we are able to see that it is retrieving perfectly. Now what I will do, I will then this is get retriever, and retriever is return. Now I can have rag pipeline. Okay, so with respect to the rag pipeline, what I can do, rag pipeline. So I can define rag pipeline, and I will have the query as an input. That is of a string type. Say this is the functions, and say root equal to LLM router, and I can pass this particular query. Okay, so LLM router, so I will be having the root. So we have just done the testing over here. Let me delete this. So I'm having the root that is decided by this LLM router. Now I can print it, print it in a good way. Say hmm,
LLM router की spelling सही नहीं है सर. Router.
so don't focus on to the okay, but the function name is correct. Let me try to redefine it.
Okay.
Router. Okay. So thanks for the spelling correction. So LLM router query I am going to pass, and I'm going to print router query, and see this one is the query. Query I can have, then I can print, and I can have, say, router selected router. select a route, and I can have, say, this particular route. And then get retriever. Retriever equal to get retriever. Get retriever, and I can pass the route. Perfectly fine. And then I can have take dogs equal to retriever dot get. Mhm. Context equal to I can join those particular documents what have been retrieved. Mm, I can have the prompt. Context. Context. And now I can try to use this. This is the RAG pipeline. I can pass the query and I can have the answer, final answer. So get the retriever. So up to this word, take docs. Uh, retriever dot get relevant documents. It is working over here. So we are able to get the documents. That is perfectly fine. We are able to get the retriever. Get retriever. Huh? That is also perfectly fine. So it is how to optimize. This is the query, and then selected route is uh, tag. That is perfectly fine. Now this retriever dot get relevant documents. Huh? I think we are having issue over here. Print docs. Print docs. And instead of page content, it is content. Document are also coming. LangChain is good framework. Okay. Okay. So the thing is that why I am not able to get how to optimize the Python programs. What is LangChain? Hmm. There are there are multiple categories of loans. Something weird is happening over here. So documents are there, print docs, then context is can we let me try to use chat from template.
सर ये ओल्ड क्वेरी को भी ले रहा है सर साथ में।
कहीं ना कहीं लोचा हुआ है। लेट्स सी।
सर जो क्वेरी अभी दी है सर उसको क्वेरी ए करके डालना है सर।
Must be a prompt value. Okay, we just need to pass the prompt value. That is perfectly fine. So context question query. Answer the question based only on the. Let me remove only. Final prompt LLM and work. So context is fine. Response is not defined. Huh? Hmm. Huh. Okay, so the main issue was like the response, this spelling was not defined properly. Response. Okay, so this spelling was incorrect, and we are getting all of these particular issues. One spelling mistake, and we were able to get the issues. So now it is able to take answer to the question. It looked like the context and the question were not provided. Please paste the actual content like this. So, what is the issue? So query 2 is this. So context is equal to context. Answer to the question, it looked like context. Hmm. Final prompt. Context. Okay. Hmm. This is the context. Spelling is perfect. Context is this one. Once we are going to call this query to, then query is coming from here. Hmm. Then query. This is perfect docs. Query, then context. Then context is this one, query is this one. Things are looking fine. Now why it is saying context is not defined? Final prompt. Okay, that is fine. Context is there, query is there. Answer to the actual. Please paste the real context in these formats. What is LangChain? Did we get the context over here? Context is there. Although like it is not coming. Answer to the question. So issue is over here only. Let me use the formatting. Hmm. So this is coming. Answer to the question, LangChain is described as a good framework. The context also note that there are multiple categories of LangChain. Huh? Correct? Are you able to get, because of this F, the formatting stuff, we are getting the issue. Although like I used previously, but I removed it. Okay, let me explain it once more. So what we have done, we have defined the router, LLM router over here, which is going to take the root prompt. Okay, and inside the root prompt, what we have mentioned that just need to provide us the two keywords as an output based upon these particular examples. So it is able to provide the finance or tech category, and based upon that particular finance category, we are going to get the retriever. And once we are passing the query, so the query is this one, and the selected route is the tag. Now this is perfectly fine. We are able to get the route from the LLM router, the function what we have defined. Now we need to select the retriever, and we are just going to define retriever from this particular route. Okay, so route is tag, and then retriever what it will be. This particular definition is looking over here. Okay, so if it is say tag, then tag retriever. If it is finance, then finance retriever. Okay, if nothing is there, then it will you can say provide the tag retriever, and that is you can say default functionality what I have mapped now. Okay, so that is perfectly fine. It might be say tech retriever, it might be say finance retriever. Now I'm having the question, and based upon that, like I'm going to select the retriever. So get retriever is from this. Now retriever is there, then what I need to do, I need to fetch the documents based upon this particular retriever. So doc retriever is defined over here, and get relevant documents based upon the query. Okay, so it will fetch the relevant documents. Those particular documents will prepare a context for me. Okay, context equal to, I will join these particular documents, and then I have printed the context. Now I have defined the prompt that if I'm going to pass this particular question and context, then you just need to provide me the answer in this particular way, and I'm able to get the final response. Correct? Now, if you are having any doubt, you can ask. Anyone having any doubt on top of this?
I'm good.
Although a little bit confusion was there because of the response spelling. Okay, which was used over here, it was not similar to this one, so the spelling mistake was creating the issue, and this formatting was creating the issue. So once we are using the prompt inside the function, then we just need to have the formatting related stuff. Okay, so once we have corrected this, then we are able to get the outcome. We can remove this print context as well, and then we will be able to get the output. Perfect. What is LangChain? Then based upon the LangChain, it is going to provide me the output. Okay, answer to the question, LangChain is described as a good framework. Okay, simple. Perfect. Are you able to get the routing
Yes,
as well?
yes. Yes.
Okay, perfect. Now, okay, so I think that's it for this particular session. We just willing to cover uh, the routing technique. Now what you need to do, you can take it as an assignment. Okay, you can perform the semantic routing based on the embeddings as well. Okay, assignment embeddings based routing. Okay, you just need to explore this one as well. Okay, it is really very simple. What you need to do, let me provide certain context over here. So you just need to define uh, the roots and say tag root, say the question about the data engineering, Spark, LangChain, Langsmith, ETL. Then finance route, the question about the loans, banking, interest, credit score. Okay, so you are going to define those particular routes, and then you just need to define the key, and you can say values, and based upon that you will be able to get the semantic route. Okay, so just try to explore this one, embedding based routing. Inside the routing mechanism, so embedding based routing users need to explore. If you are able to get, then that will be fine. Otherwise we will start our day next session with the embedding based routing, and then we'll proceed for the indexing. That is very simple to implement, and then we will proceed for the next, you can say, we will be having one project probably in next week. Okay, and we'll start how to handle structured data with the help of the tools. Okay, we will be going to create certain tools, and we'll start handling the structured data with the help of RAG models or RAG chatbots. So that we will learn in our next session, and then we'll start the land graph. So langchain and the advanced uh, rag optimization will be over in next week. Then we'll start lang graph and handling structured data, and then we'll proceed for the fine tuning part. So that's it for this particular session, guys. If you are having doubt, you can ask. Let me stop recording.